Hi, good evening, everyone. Can you hear me? Hello, guys. Can you confirm on the audio and the visuals? Can you hear me? I'll just share the PPT. Let me know if you are able to, see the PPT as well. Okay, I have shared the PPT. Just tell me if all you guys are able to view it. Is that visible? Huh. Okay. I think we in the last session. Okay, that happened last Monday. Last Monday we cannot have a session, okay, because of some other engagement that you guys had. So we completed the basic discussion of the questions on basic theory of the percentages, and we just began actually with the questions. To the best of my knowledge, I think this was the last question we discussed, right? Uh, did we do the successive percent change? I think, yeah, we did this as well. This was the last question. Yeah, just guys help me out. Anna, we did the successive percentage change, and I think we did this one as well. Done this, right? Okay, great. How about this one, the next one? We didn't start with this, right? Yeah, okay, okay. So this is our next question. Let's try this. Okay, chalo. Let's try this one. Okay, take a minute, go through this, and it is a multiple answer choice question. So which of the following statements are true? So it's more than one answer possible. Okay, so evaluate all the options and see which of these five are true statement. Okay, let's check that out. Okay, start. Okay, guys, let's see. This is a bit time consuming question because each statement is kind of a condition in itself. It's like a small mini problem. I can't say it is a big problem in itself, but this looks like a kind of a mini problem. Okay, that we can quickly check up with by taking some certain values and then work out. Acha, before we go, another one important thing just to check. Have you all guys marked your attendance? Because I guess Samyuk has a sheet that he shares about the attendance part. Okay, Samyuk, you are there? Okay. So is Samyuk there? He joined today? Okay. I think last time Samyuk has done that. Okay, so can just one of you, okay, make a Google Doc and share it with all the others for today? Because for me, I see there are 51 attendees here, 50 attendees actually. Okay, that shows also me as one of that part. So maybe, if you can just somehow, one of you can quickly document that so that the attendance is taken and actually this goes to your respective heads as well. Okay. So I'll just take a screenshot from my side and you guys can also quickly run through that part. Okay. So that you also, one of you may take the initiative and make a sheet where all of you just input your names so that you have the records for the today's test. Okay, chalo, let's check this. Which of the statements are true? Okay, if an article is marked at 120 and discounted to 90, the percent discount is 25%. So you are reducing the value here from 120 to 90, which is a reduction on 30 on 120. Okay, initial value, final value as a seen. Okay, so that is 30 and 120, 1 by 4, which is 25%. Okay, so A is true. B on the other hand says if this was marked up, so from 90 to 120, if it was the markup thing done, then it will still be an increase of 30, but on the value of 90. So this would be a 30 on 90, which will be 1 by 3. And hence the markup will be 33.33%. Okay, not by the same as 25%, because the difference here is the same, but the base would change. When you mark down or you gave a discount, it was the base of 120, and you're doing the mark up, then it was be on the base of 90. So since bases are different, the respective percentages will also be different. B is wrong. Now let's look at the third one. That says a salary, you know, increased by 30% and reduced by 30%. Then what the overall reduction is 9%. Okay. Now you can just take a number and work that out. And I'll tell you another shortcut for this one that can be worked out. So let's say originally he had, you know, a 100 cut thing. So he first get increased by 30%, which is of course plus 30. So 130. And then he had a reduction of 30%. 30% reduction. Now 10% is 13. So there will be a total reduction of 13 into 3, okay, which is 39. So he increased first by 30, but now decreased by 39, which means he lands up at 91. So originally, if he had a salary of 100, now he lands up at 91, which is 9 less compared to 100. Okay, and that is 9% down. So his the reduction is 9% of the original salary is now 9% less on the original. This is true. Okay, so 9% part is correct. Yeah, C also is correct. Now, if you look at this again, is a successive percentage change, and whenever you can take it now as a formula, directly. Whenever we have a successive percent change, as we did in the earlier part, if you have a X percent thing followed by another Y percent, then the overall successive percentage change would be x plus y plus xy over 100, the whole percent. This is as a percent thing. And we have seen how we used to use this depending on increase hai to positive value, decrease hai to negative value. You take x and y as positive and negative depending on the increase and decrease. Now, when you're doing a successive change of first increase and then decrease by the same percent, so the first one you increase by x percent, and let's say the second one you decrease by x percent, or vice versa. Now, this is your y value now. So this is a case where your y is minus x. So the overall percentage that you get would be x plus minus x, then plus minus x into x the whole over 100, right? Now this term will get cancelled and you'll be left with minus of x square over 100%. So in this case, in this scenario, you will always have a loss. There will always be a reduction, come what may, whether you first increase and then decrease, or you first decrease and then increase. Effectively, there is always going to be a loss, and the loss is simply that x percent value, jo diya hoga, that square upon 100. Now, in this case, you see the x value is actually 30. So I can directly say plus 30 minus 30. So 30 square, that is 900. 900 on 100, which would be 9. So hence there has to be a reduction of 9%. Okay. So in this case, you can generously solve it by this one. Uh, Thank you, Shantanu. This is the link for the attendance, right? Okay, great. So all of you, please, in the meantime, do visit the link and write down your name, mark your attendance. Okay. Shantanu, can you also share that with me so that I also have it for the record in the end of it, after everyone has marked their attendance? Okay, just you can mail me the copy of it so that I also have it for the record. Okay, thank you so very much. Right. So in this case, whenever you're having a following successive percentage change of at first increase and decrease by the same percent, you'll always have a reduction of x square on 100%. So this is like, a tradesman increase the selling price of his article by 25%, and then later on he decreased it further by 25% due to fall in sales. So पहले उसने 25% increase किया, sales कम हो गई, then he reduced by 25%, whether he's making profit or loss as compared to the original price. So here we see that X here is 25, and since it's a successive change of the same percent, increase, decrease, he will definitely have a loss. And the loss percent is given by 25 the whole square divided by 100%. Now 25 is 625, 625 on 100, which would be a loss of 6.25%. Okay, so he will be making a loss of 6.25%, right? So we saw the first is true, second is false, the third is true. A single discount of 33.33 is equivalent to two successive discounts of 16, 2 by 3, and 20. Now this is again, you can do that from the formula. The only thing is here you have a decimal percentage value, 16, 2 by 3, which is not a very integer value. Okay, but now what you can do is 16 2 by 3% is equivalent to what fraction? Can you quickly tell me what fraction value is 16.66? Yeah, 50 by 3 would reduce again as a fraction, the standard fraction. This is still 50 by 3 is still in percent. Which fraction is equivalent to 16 2 by 3%? Remember we did that last time. This is 1 by 6. 1 by 6, yes, correct, correct. Akshat, 1 by 6 is 16.666, and 20% actually is equal to 1 by 5. So what we see as in percent, it is nothing but 1/6 and 1/5. He reduced first by 1/6 and then later on by 1/5. Now I can simply take, let's say the base price as 60. So पहले 16.66 से reduce किया means 1/6 reduce किया, 1/6 of 60 is 10. So he reduced by 10, got 50. Again, he reduced by 1/5, which means another decrease of 10, which is 40. So something that was listed at 60 is now sold at 40, which means there is an overall reduction of 20 on 60, which is 1 by 3, right? And 1 by 3 is nothing but 33.333, right? Correct, correct. Yeah, we'll come to that also. You're true. Okay. So this is same as 33.33%. Okay. A single discount of 33.33%, which is very much equivalent to a success discount of 16 2 by 3 and 20. Correct. So this fits in, and hence D is also true. Yes. Okay. Let's go through this again. So what we did, okay, I just tried to use the value here of fractions instead of using the percent. Okay, so I'll try to solve it in both the ways. The first 16 2 by 3 will reduce to how much? 50 by 3, right? So let's take the normal successive percentage wala formula. 16 2 by 3%, I'll say this is 50 by 3%. So ये हो गया x, and y कितना है, and then later on 20%. So equivalent, effective value is then 50 by 3 plus 20, you know, plus 20 into 50 by 3, the whole over 100. Now that 100 part actually can be cancelled with the zeros here. So that becomes 10 by 3. This is 10 by 3, right? And 20, actually I can look it as 60 by 3, so that I have everything on 3. So finally, the effective percentage change would be 50 by 3 plus 60 by 3 plus 10 by 3. So 50 plus 60 is 110, 110 and 10, okay, would be 120. So 120 by 3, right? They all increase, right? Two successive discounts. So sorry, there's a discount. So this is minus and this is minus, and this will be a plus. Okay, minus 50 by 3, minus 60 by 3, plus 10 by 3. Sorry, you need to take the sign also into consideration. So it's a discount, so that would be negative, and the product would become positive. So minus 50, minus 60 by 3. Okay, taking 20 as minus 60 by 3, which will be minus 110 by 3, and then minus into minus, which will become plus. So therefore, overall plus of 10 by 3. So which will give you 100 by 3. Okay. Now 100 by 3 is 33.333% recursive, right? So the effective percentage would be 33.333. This is by using the formula. Okay, you can use the formula for the successive percent one. What I did, okay, in the previous method, I just said that, okay, instead of using the percent, let's use the fractions. So we saw the 16 2 by 3 is actually 1 by 6, which 1/6 part, and 20% actually is 1/5. Okay, so 1/6 है. So let's say the original value be 60. Okay, and then I gave a discount of 16 2 by 3, means I discounted it by 1/6. 1/6 से कम किया. 60 1/6 is 10, so I reduced it by 10, so that reduces to 50. And then this 50 you further reduce by another 20%, which is 1/5. 1/5 of 50 is again 10, so that means now it is at 40. So an article which was listed at 60 is now sold for 40, which means the overall reduction was 20 on 60, which is equal to 1 by 3. And 1 by 3 is 33.33%. Okay, so instead of using the successive formula wala, that rule, I just converted these percentage to fractions, took a number which is evenly divisible by 6 and 5, which is 60 only, 30 भी ले सकते थे, but then 60 just directly work out हो जाता है, and then so okay, what is the overall percentage decrease, right? So we say A, B is not, C, D all correct. Now let's look at the last one, E. If cost price of two articles is 100 each, so this is 100 and this is 100, he gains 5% on this one, and the another one he loses on 5% of this, both on the cost price. That means he sold for 105, and 5% loss. That means he sold for 95. So the total cost price here is 200, and the total selling price, after the profit and the loss, which we saw, is also 200. So he had a cost of 200. He sold for 200. So the profit percent, okay, made is actually zero because there is no gain, no loss. So hence, in the end, there is a no profit, no loss. Right? So then there is no profit, no loss on the entire transaction, which is true. So hence E is also true. Okay. So for these five statements, except B, all the other four, A, C, D, and E, turns out to be true. Okay. So that would be the correct answer. A, C, D, and E. Now, a small change. Instead of a CP here, let's say this was SP. Okay. Instead of a cost price, this is selling price. He sold, you know, two articles in 100 of as a selling price of 100 each. On one he gained 5%, on the other he lost 5%. Did he gain or loss in the overall transaction? Now for the selling price, try this out and tell me whether he will have a profit or a loss or a no profit, no loss, and by how much percent. Okay, try this out. This is also another type of a question where selling price is same for both the articles instead of the cost price. Okay, try this out. Okay, he will have a loss, right? Okay, no profit, no loss. Okay, the question is instead of cost price, if the selling price was the same, he sold for 100 each, two articles, where the selling price is the same. On this, let's say he made a profit of 5%. On this, he had a loss of 5%. Okay. Then overall, did he gain or lost in the overall transition? Yeah. So in such cases, he will always have a loss. Okay. There is a direct formula which you can simplify and then reduce it to. Okay. So I'll just directly get into that one. So if the selling price of two articles are the same, let's say X, and on one, if he's gaining, P%, and on the other, he's losing P%. Okay. Then in this case, he will always suffer a loss. These always suffer a loss, and the loss is actually equal to that p square over 100%. The loss would be just like, you can relate this to the same problem as the two successive percentages case, where in one case he increases by x percent and the other one he decreases by x percent. So you'll say In this case, he will always suffer a loss, and the loss percent is given as p square upon 100%. So like here, we see the p equals to 5, right? P is 5%. So his loss percent in that would be 5 square, which is 25, 25 upon 100. 25 upon 100 is 0.25%. So he will always have a loss of 0.25%. If you have to find out the actual value of the loss, how much is the loss? Okay. Then if you have to find out the loss value, then it is given as 2 into p square, okay, into the selling price upon 100 square minus p square. Okay, this will be the actual value of the loss that he would suffer. Okay, like in our case, if we try to find out how much did he lose, what is the loss percent, then we can say, not the percent, the loss percent would be this, but how much did he lose, then it is 2 into p square. P square would be again 5 square, 25, into the selling price, which is 100 here, as we see. And this is 100 square minus p square, which you can write it as 100 minus p and 100 plus p. That will be 100 minus 25, that is 75, into 100 plus 25, which would be 125. Okay, so you can simplify this further, the 25 and 3 times, and this is 4 and 5 times. Okay, so that will be 4 into 2, 8, around 3 fives are 15. So therefore 8 over 15, nearly around half a dollar. So approximately half a dollar. Okay, rounded to that one. So this will give you the value of the loss exactly. Okay, and this formula will give you the percentage loss. Okay, so in this case, again, you can avoid taking the numbers as 100 and try to find out the cost price in the first case and cost price in the second case, and then see overall total sum of the cost price compared with the given selling price. You can directly use these formulas. Okay, they are just derived by taking that into account, and hence you can directly find out the values of the percentage and the loss. We don't use this for the cost price because the percentage values are calculated on the cost, ना? तो एक केस में 100 अगर कॉस्ट प्राइस था तो 100 का प्लस 5%, and in the second case you are taking 100 का minus 5%. So since the plus x percent and the minus x percent are both calculated on the cost value, so the gain and the losses are equal and hence gets cancelled out, right? What will happen here is that the cost price would be different. Is the final after adding 5% and subtracting 5%, they become equal. Okay, so the situation here, okay, is something like if you had the cost price equal, let's say CP, now you do X percent, you know, and you do minus X percent. So you get the selling price. This is SP1 and then SP2, right? Now, since these both X percent and Y percent are calculated on the cost, so these values are equal. So when you will add them out, they will cancel out. Okay, so you won't get any gain or a loss as such because they even out and give you to the same value. So the total selling price would be equal to the total cost price. This is 2 times the cost because there were 2 cost values. What is happening in this case, the selling prices are equal. So there is this CP1, okay, which you decreased by X percent and you got a selling price for this. And there was this another CP2, which you increased by another X percent. And after that, it is coming out to be this. So in the second scenario, you have different cost prices. Where you had a loss of X percent, it reduces to a selling price value. In the second case, you have a different cost price, which you increase by X percent, and it also gives you the same selling price. So the two selling prices are equal after subtracting and adding the X percent of their respective cost prices. So that's why they will not be the same because bases are different, right? So in this case, this decrease, is on the larger number and this increase is on the smaller number. So this decrease is always greater than this one, right? So therefore you will always suffer a loss because जो reduction है वो बड़े number पे हो रहा है and increase छोटे number पे. So overall reduction would be less. That's the reason why you will have a loss always. It will always give you a loss because the bases are not equal, right? Although the percentages are equal, right? Okay. So that was the final answer. But remember that formula because it saves a lot of time. You just substitute and calculate. That will give you the answer directly. Okay. Chalo, let's go on to the next one. So here we see the answer is A, C, D, and E. Right. Oh. Okay, let's go to the next then. Yeah. Okay, let's try this. Okay, chalo, let's see. It says during the sale, a shopkeeper was supposed to reduce the price of an article by 25%. Okay. So sorry, by 15%. But instead, by mistake, he increased it by 15%, and the consumer has to pay 450 extra. So what was the price paid by the purchaser? So we can see that if the original price was X here, he wanted to reduce it to 85% of X. That should have been the actual price at 15% reduction. But this guy actually ended up increasing it by 15%, that by increasing into 115% of X. Okay, which resulted in overall a 30% increment. Because instead of minus 15, you have a plus 15. So you see the absolute gap in between here is 30%. And this 30% is 450. Right? So, and hence consequently, the consumer wanted to pay this price, but ended up paying this price. And eventually he paid 450 extra. So this difference of 30% is equal to your 450, right? Now, if 30% is 450, then you can say 10%, you can just do that orally, would be how much? 150. And if 10% is 150, that means the original price is 1500. So the original price of the article is 1500. That you can get that directly. 15 minus 15, 30% का decrease है. 30% is 450. So 15 threes are 45. So 10% is 15. So hence 100% is 1500. Now, once you got 1500, what we need to find? This or this? Okay, ये चाहिए कि ये? It says what is the price paid by the purchaser. This is what the purchaser paid. So hence plus 15% more of this. So iska 1% of 1500 is 15. So 15% कितना हो जाएगा? 15 into 15, 225. So he paid 225 more, and hence this value would be 1725. Also by the same logic, this would be less than 225. Actually इसको 225 से कम करना चाहिए था. He was supposed to reduce it by 225, but he actually ended up increasing. So the real price that the customer should have paid, okay, would have been 1275. Okay, so this is what he paid, and hence the answer is option D. Okay, now observe how carefully and how uh, they make the options. So you have a value of 1500, which is the original price. So someone who will take a x and solve for x will get x equal to 1500. He might mark that without reading what is asked. Okay, you also have a value of 1275, which is on the reduced price, but that is not what is asked. And you also have the value someone would have calculated 1500 properly, and 450 is the extra, so he may add up 450 instead of splitting it half and half. Observe 225 and 225, these are the half of 450, which are what the basic difference is. So 225 plus 225. So this is 1500 plus 450, which is 1950, and 1500 minus 450, which is 105. So whatever type of a mistake, whatever kind you make, you will always see one of the option fitting into it. So these options are also carefully designed. They're just not randomly planted. Okay, they see what are the possible mistakes that you can make, so that in a hurry, if you committed one of those, you will also see an option there and give you no chance to actually go back and rectify it. Okay, so be very careful about we are marking the right answer. So read again, verify what is being asked after you have solved the entire question. See what is unknown and what is what you need to mark for, and then and only then confirm your answer. Okay, otherwise you would have done everything right. It's just that you ended up marking a wrong option just because you didn't read the question carefully. Yeah. This is what we call as a silly mistake, right? So answer D is correct. Perfect. Okay, so others who marked B or in E, again you made one of this mistake. You ended up actually adding 450 instead of 225, and for the B one you ended up actually subtracting, instead of adding. These are the two mistakes. Now, coming on to the application of your simple and compound interest questions. So now, how do I use the percentage rule, or how we apply the percentage thing on a simple and compound interest? Now, simple interest, as you know, it's a very direct thing. The interest is always calculated on the principal, which is R%, or it's also called as a PCPA value, which is percent per annum. So the rate value that we have here, okay, this R is always calculated on a PCPA, percent per annum. So whatever is the mode, whether half yearly, quarterly, or whatever type, the R% value is always yearly rate. Remember that. If it is half yearly, as you'll see, or quarterly, you need to divide it further and reduce. Okay. You don't have R directly for half yearly or a quarterly. It is always and always for a yearly basis. This is the thumb rule. So remember that. Okay. And then is the number of terms or number of times actually you would calculate. You will repeat the interest part. Right. Now, if the interest is given quarterly, number of quarters, and R is quarterly rate of interest, and so on. Okay. Now, this has to be given. Okay. So, if it is in a monthly, on a half yearly or quarterly basis, R is for a year. You take R by 2, R by 4, R by 12 as the value for your rate of interest. Okay. Now, on a compounding basis, you don't have a formula which directly calculate uh, the interest value, just like you have simple interest. Okay, so you get this for the amount that you get in the end, because the compound interest again is nothing but a successive percentage calculation. So every time, every next year, you keep on finding R% of the previous value, not the original value. and hence you can see this is nothing but the successive percentage calculation done for n cycles. So the same bracket multiply n times and hence comes as the power of n. Okay, P is the principal, R is again the rate, which is in terms of the yearly rate of interest. And if you're calculating for a half yearly or a quarterly, then you have to take this as half or quarter, okay, when you are solving it out. So you take half of R by 2 or R by 4 or R by 12 when you're doing it for the yearly, half yearly and a quarterly times. Okay. Now, as we see in here, the compound interest, that was the formula for the amount. The compound interest would be the amount value minus the principal value that you have. So minus P that you have additionally. Now, okay, we'll just take it in this case, how the compound interest formula would look annually, semi-annually, quarterly, and on a monthly basis, right? Okay, so in an annually basis, I'll just actually deduce it for amount only. It's just the minus principal that we need to do. So annually, the amount value is P1 plus R over 100, the whole raised to N. And then using minus P, which should be the case for the annually basis. On a semi-annually basis, the amount would be, now, if I'm charging 10% on a yearly basis, okay, that's PCPA. On a half yearly basis, of course, I would be charging interest at half the percent. Okay, but on a yearly basis, you charge interest at the end of the year, so only once in a year. But on a half yearly basis, you will charge it after every 6 months, which means you're going to have twice calculated. The interest would be charged twice, and hence the number of years or the number of times the terms would become double. So here you're going to have the rate decreasing by 2, so R by 2 on 100, the number of cycles becoming double. एक साल में 2 बार, so 2 years में 4 times, 3 years में 6 times, and so on. Of course, this is the amount minus the principal, which will be the interest. Similarly, on a quarterly basis, we'll have 1 plus R by 4 on 100, right? It becomes 1/4 of the 100, so fourth value. So if it's 10%, it will be 2.5% every quarter, and this becomes 4 times. So the number of times you calculated would be 4 times in a year. And hence it will be calculated 4 times and hence 4. Right? So that would be the case on a quarterly basis. Whereas on the monthly basis, P 1 plus R by 12 on 100, and the power become 12 times L minus P. That will be the difference that you will have when you're calculating the compound interest on an annually, semi-annually, quarterly, or the monthly basis. Now, in most of the cases, you don't get into a monthly calculation because the power is way too big, either in case of 1 year interval itself. So although you have a calculator, but that is the normal calculator, which have only square function. Okay, so you don't have the x raised to n wala function where you can calculate directly any nth power. Okay, that is a part of the scientific calculator, and this is the normal calculator. So that becomes again quite calculative to see that. Whereas quarterly would still be possible because it's just like you square and square twice. Okay, so you can still expect a quarterly based questions, but monthly it's quite rare, becomes way too complicated to work. So this can be just used as a knowledge purpose. So if you say taking out in the ratios or working out in some other way, instead of directly asking you to solve and find a value for the monthly times. Okay, so this is the case when you calculate compounding on a different basis. Now, if you're doing this on a simple basis, it doesn't matter. Because if you see the simple interest formula, which you get the interest, it's P into R into N over 100. Now, if you do it on a semi-annually basis, the interest part, P would remain the same. You will see that R becomes half and n becomes double, so it doesn't matter. The two gets cancelled anyway. So it's same as the yearly basis, right? Which is PRN. Quarterly may you will have a 4 here and a 4 here, which will also get cancelled. Monthly you will have R by 12 and 12 times n's. So whether it is semi-annually, quarterly or monthly, the factors, when the R by 4 and then there as a 12 will get cancelled. Okay, whatever the mode, and the final sum is equal to what you paid for the entire year. Whether you break it into 2 installments of 6 months, 6 months, or 4 as per quarter, or 12 as per monthly. The total value paid is equal in every case on a simple basis. Logically, that makes sense because the principal value is what you're calculating on. So all the rate of interest are calculated on the principal value, which is constant. So you break it in two parts or you add them up all. It will always be the same. So remember, for compound interest, the interest part is not constant. Interest varies, interests are different, and that's why your breakup part will not add up to the same sum as you will have it for the year, because the base value keeps changing, and hence the respective percentages will also change. Also, a very important point to remember, okay, if you have to use at some direct shortcut rails, by the very nature of the formula, SI is P into R into N over 100. It's expressed as a product of PRN. So you can say that simple interest is actually directly proportional to the P, also to the R, and also to the N. You can keep all the other things as constant, and you say the other would change, the interest would also change in the same factor. So if principal becomes double, the interest will also double. If rate of interest becomes 5 times, the interest would also become 5 times. If the number of years becomes half, the interest will also become half. So simple interest will change by the same factor as any change in your principal or rate or n. You can directly calculate that. You don't need to get into values and calculate and check. You can just use the proportionality. Say for example, it is given that for the same principal, if the number of years were trebled, okay, but the rate of interest is halved, what would be the new interest, or how much more would be the interest now as compared to the previous one? So R becomes half, whereas N becomes 3N. So we'll see the interest will also becomes 3 times because of the period change to 3 times. Interest will also become half, which was of this one. So overall, the new interest will now be 3 times of n but half of r, so 3 by 2 of the original value. So hence the new interest would be now 1.5 times the original. Okay, that you can directly deduce just because they are not proportional to each other. Now the same logic will not work in the case of compounding. That will not work because the interest part is not common. So we see the compound interest is P common, okay? It's 1 plus R over 100 raised to N minus 1. So it is expressed as P into this whole bracket. This whole bracket, having a practical inference of this bracket is doesn't make sense. What would that stand for? But we can see this as this call it as a constant K. It's only K times P. So compound interest is only proportional to principal. You can say CI is directly proportional to P, but not to R, not to N. So if you double the interest, the compound interest won't double. If you treble the number of cycles, it will not treble. But if you, let's say, make principal 5 times the original, then in that case, the compound interest will also become 5 times. So the proportionality rule can be used for all the three for simple interest, but only for principal in the case of compound interest. Okay, so these were some ways you can work it out with. Now let's go to the questions and try this out. There are again some good number of shortcuts available, which we will see. Okay, let's start this one. This is simple. Okay, so what is the answer we are getting for this? See, 816. Correct. Now, there are two ways you can look at it. Okay, it is given to calculate compounded semi-annually. So the principal value here is 10,000, right? R percent, which is for the year, is 8. Okay, it's 8%. As I said, it's always annual rate of 8%. Compounded semi-annually, that means for our calculations, we're going to use R by 2, which is 4%. Right? Okay, now it's given compounded semi-annually. So question will always speak of that. It should be given in the question whether you're doing it on a simple basis or on the compounding basis. If it is on a simple basis, whether half yearly and all these things doesn't matter, huh? Okay, but again, as a thumb rule, if you would see, if the question it's not given in the question, then it is always to be taken as compounding unless it is mentioned. So the rule says that if question doesn't mention, then it is taken as a compounding interest. If it is simple, then the question would speak of the question, it would be mentioned in that part. But as far as GRE questions are there, I have never come across such a ambiguity. They always mention it, just to be more double sure that whether it's on the compounding or the simple basis. Okay, so that confusion may not come. So the only thing here is its annual rate is 8. Don't take it as a half yearly. So for a half yearly, you have to take by 2, which is 4%. We have to find what is the total amount paid at the end of the first year. So N is 1. Okay. Then we can say the amount that we'll get would be P, 10,000, 1 plus 4 over 100, the whole square. Because for n it becomes 2n, which is twice 6 months and then 6 months. Now such questions will always, okay, involve a square, because for 2 years or for semi-annually, so which is 10,000. Okay, this I can say is 104 the whole square over 100 square. Now just split, you don't take a decimal because this 100 square actually gets settled out with this 10,000 here. Okay, most of the time the value would be such that they will cancel out. So that part is gone. Now all I need to do is calculate this 104 the square. Now remember this method. Okay, that comes again from the Vedic math. Whenever we have to calculate a square close to a number 100, let's say 100 se thoda zyada, like here 104 square. See the difference from 100, which is plus 4. Now square 4. Whatever is the difference, square it. So plus 4 square is 16. Write this out. And then add this to the original number. So 104 plus 4, which is 108. So therefore, 104 square will be 10816. So you get the value as 10816. Okay, directly. Now this is 10816. This is the amount. The principal value was 10,000. So we subtract, and hence the compound interest value is 860. Okay, so you get the compound interest as 816, which is option C. Okay, so this is how you can work out. And generally, in interest-based questions, you have things like 5%, 7%, 10%, 12%. So you will generally have questions for which we need to calculate squares for 107, 108, 112. So for any value that you have close to 100, let's say if I have to calculate what is 107 the square, you just see the difference is 7. So plus 7, 7 square is 49, 107 plus 7 is 114. So hence the square will be 11449, 11449. Okay, if it is 112 the whole square, see the difference is 12 square, which is 144. Now you need to write only the last two places, right? So that's plus 44, 1 caret. Okay, should fill only the last two digits. of this square here. So 144 ka 44, 1 caret, 112 plus another 12, which is 124 and 125. So therefore, the 112 square is 12544. Okay, so here you need to be careful again when you're dealing with, let's say, a square of 101, 102, and 103, where the difference is a single digit value, which is +1, +2, +3, whose square is also a single digit. Let's say it's +2. So it's 2 square is 4, so hence 0, 4. So 102 plus 2, which is 10404. So you get this as 10404 as a square. Okay, so that's the only thing that you need to be careful, right? Of course. Now, the logic is very simple. If you need to find an 8 square, I would just somehow modify it by adjusting another square to it. So I add, a minus b square and a plus b square, and this b value is chosen in such a way that this calculation gets simplified by a value. So here you see this would expand to a minus b and a plus b, and will give you a, sorry, in this case, a plus b square. Right? So this is equal to plus b square. Right. Now in this case, let's say if it was 104 square, I would choose the value here so that one of these bracket actually turns out to be 100. So 104 minus 4 will give me 100, because when you multiply by 100, you don't have to bother. It's just last two digit, which is 0, and here you will have 104 plus 4, and then since I choose the b as 4, so this is 4 square. Now this product is going to be 108 into 100, so last two places are 0, and hence 4 square, which is 16. So last two digits will always be the same as this one. Okay, that's why you can identify the last two places very quickly, because you want one of the brackets to be equal to 100, and hence this will give you, the last two digits as 0. So that's why we write only the last two digits, and hence everything else is carried forward. Okay, and then the other bracket we add 104 plus 4. That's the reason why you're adding it back. So hence the square can be simply 104 plus 4, which is 108 as a higher decimal digits value, and then the last two places comes as 4 square, which is 16. Okay, that's the simple logic for this method. Now you can also use this in case if it is smaller than 100, because in that one a plus b becomes the 100. So that's a case, when let's say you take a number which is less than 100, 96 square, which you can write it as 96 square minus 4 square plus a 4 square. So the last digits are 16, which is a 4 square, and this becomes 96 minus 4 into 100, which will give you 96 plus 4. So in this case, if the number is smaller than 100, you will not add to 100, you will actually subtract from the number. So like in the previous case, you were adding to the number, right? 104 plus 4. If it was greater than 100. In the case, if it is lesser than 100, you will subtract. Okay, 96 minus 4, which would be 92 and 16. Is that clear? Right? So that is how you can calculate the squares of all the numbers smaller than 100 and closer to it. Right? Any questions on this? Right? Guys, can you hear me out? Yeah. Okay, clear. So this is how we can work out. Let's go to the next one, next question then. Okay. Now this is one way where you will be using a square. Okay, for the square calculations, we need to get into finding the squares. Other ways where you can actually avoid getting into the square or formula and then use this simply by logic. So since you're going to be paying the interest in the 2 installments, first 6 months, and then let's say the next 6 months. Okay, base is 10,000. Rate of interest is 0.5%. Remember, you're going to pay the interest on principal for every cycle. It's not that you'll be spared to not to pay the interest on the principal. So here 4% of 10,000 you will pay in the first cycle as well as the second cycle. So 4% of 10,000 would be 400. 1% 100 है, so 4% 400. तो ये 400 इधर भी आएगा, इधर भी आएगा, right? Which is 800. The only difference on the compounding here is then the simple interest. Simple interest hota to ye ho jata. In case of compounding, you also charge interest on the previously paid interest. So whatever is the previously paid interest, you charge R% of that as well. So the additional part that you will charge here will be 4% of the first interest, which is 400. Okay, now 1% is 4. So 4% will be 4 into 4, which is 16. So hence the total interest value, this will give you directly the interest, not the amount, will be 400 plus 400, 800, 800 plus another 16, which is 816. So in this, you don't need to do any calculation for squares and all that. No formula. Just find R% for the first two intervals on the principal and then just add only R% of the first interest. The sum is the total interest value that you get. Okay, as we have seen that one. So this will give you the answer of the difference or the interest directly from that. Okay, also if you try to work out the difference between compound interest and simple interest, you know, CI minus SI, you can simply write this as P into R square over 100 square. Okay, so if for a given, you know, for 2 years period, specifically, if they have to find, they ask you what is the difference between the simple interest and the compound interest paid, okay, by a person in case of 2 years, where he had borrowed a principal of, you know, a certain value at R% of the rate, then this difference is directly given as P into R square over 100 square. Okay, this is difference of the simple and compound case. Oh, let's go to the next question. So 816. Okay, let's try this. Okay, let's see the answer. Only three answers. C and C. What about others? See. So generally, this is a case where it's given that the amount, let's say whatever value we are investing, okay, if original value is P, this gets doubled. Investment will double, so becomes 2P in approximately how many years? The time interval, okay, N is approximately 80 by R percent value, the percentage value that you have. Of course, the percentage means you don't need to take the 100 there. It's just the number that you have. Okay, saying that percent here is not at all relevant. That doesn't mean a 100. Okay. Now, if Sandra's parent invested 10,000 in a fund that pays 9% interest, compounded annually. So again, it is on a compounding basis. What will be the approximate total amount in 18 years? So first, let's see what is the tenure in which the money gets doubled out. Okay, so the n, the number of years part, is approximately equal to 80 by 9. Okay, that we can again round off to somewhere around 81 by 9. Okay, 80 and 81 hardly would make 1 by 9, which is fractionally 0.111 ka difference. So that is equal to 9 years. So we can say that the amount gets, you know, doubled in every 9 years. So every 9 years it will just keep doubling. So right now you start with 10,000. Okay, invest this, keep it for 9 years. The value becomes double, become 20,000. Since they are doing for 18 years, which means they're doing it in two cycles. So take this number, take this amount, and reinvest again for another 9 years. So that continues. You reinvest in the same scheme, and this will double it again after 9 years, which will make it 40,000. Right? So you start with the 10,000. First 9 years becomes 20. Another 9 years it becomes 40. So therefore, what would be the total approximate amount in 18 years? It would be, of course, slightly less than 40. But if we have to see the approximate or the closest option to that one, that would be 40 itself, and hence the correct answer option is C. Okay, so C is the right answer. So it's going to be 40,000 in the end of the year. Directly, okay, you're saying the compound interest formula? I mean, this is just the direct thing. Huh? 9 years में है, दो साइकिल्स होंगी. फर्स्ट साइकिल में 10 का 20 हो जाएगा, 20 का 40 हो जाएगा. फॉर्मूला में actually becomes a little lengthy, यार. I mean, you need to do the calculation. Of course, you can do that through formula also. Okay, but then what you do is use the approximate value of 9 itself, or even if you keep 80 by r, because you need to see how many cycles you need to do, right? How many times you have to go about. So let's say you're doing it in 9 years, and I'll tell you, okay, I'll actually take a case where I'll show you. You do this with a formula and without a formula, or in fact there are two variations to it. It's also a tricky and a tricky question. I'll just take that towards the end, okay, and show you that how this will work. Okay, now try this one. That's a good question. Yeah, 6% part is bigger, right? Okay. Uh, any shortcut to it? I've got one of the answer as B as well, and D. So you have D as well. How come? Okay. So first, let's see a normal method, okay, by which we normally solve this questions just like we used to do in schools. So 20,000 invested into two parts, one at 4%, the other at say 6%. We have to find out whichever one is greater. So let's say the 4% is X dollars. The 6% would be the remaining 20,000 minus X dollars. Okay. Then the total earning is 6%. Okay. Let me take this as X so that I keep the value positive. Okay. Take this as X and this as 20,000 minus X. So 6% of X plus 4% of 20,000 minus X equals to 1024. Sorry, 1040. So that is 6% of X plus 4% of 20,000. Okay, 200 into 4. Yeah, that is how much? 12. Okay, 4% and 6%. So that is 8. So 10,000, 1% is 200, and 4% of 200 would be 800 minus 4% of X. Right, which is 1040. So therefore, 6% minus 4%, that is 2% of X actually is 240. So if 2% is 240, 1% is 120. So therefore, 100%, you know, X would be 12,000. So the 6% value is 12,000. And the 4% value is actually 8,000. So after solving, yeah, you get the 6% as 12, 4% as 8,000. And that's why, you know, quantity A is greater because you have invested 12,000 at 6%, but only 8,000 at 4%. So therefore, that value is bigger. Okay, so this is the algebraic form, you know, that you can construct. So two parts, each giving you a return of 4% and 6%. So 6% on the X 1,000 values. So 6% of X plus 4% on the remaining 20,000 minus X. Okay, that should add up to the total earning of 1040. Equating and solving and finding X gives you the value of 12,000 and the remaining 8,000 of that. Okay, so this was a direct kind of a question solved algebraically, making an algebraic equation and then working it out and solving it part. Which is fine, but understand the most of the time that you're solving, you know, spending on solving this question is here in this equation. Okay, can we avoid that? Because whatever time I would save on this question, I can actually utilize on the other tough question, because this is not a tough question in that sense. Okay, this is pretty direct. So how can you avoid? Can you look at some kind of a shortcut that will work in this case? You know, in the comparison-based question that we have here. Anyone? Any suggestion where you can cut down on your method? Yes, good. And there's definitely there is a method by which you can get it quickly without actually getting into the XYZ thing. 5% interest on 1,000, so 60% should be greater amount. right? Okay, right. So 6%, 4%. But then, you know, what you can say here is, okay, now 5% on what? Again, see, it's not about the percent. 5% will be 1000 of 20. Okay, so the overall value 1040 is how much of the percent? Again, okay, that will still involve you to calculate something. What you can see here is directly, I understand, okay, what you guys are doing, which is fine. Yeah, A would be slightly greater than 5. Okay, but instead, what you can do is, because we just need which part is bigger. We are not interested in, which and what are the interests, like what is the real value, we just, or what are the values of the parts at 6% and 4%. We just need to know, okay, which of the two is bigger. Okay, so simply I can imagine if they were splitted equally, अगर दोनों equal में split 10,000 and 10,000. Okay, if the amount principal was splitted in an equal way, इसका 6% कितना आता? 6% of 10,000 would have been 600. 4% of 10,000 would have been 400. The total earning in that case would be 1,000. Correct? So if I would split the money equally, say if it was C, then my total earning will come out to be 1,000. But what you see here is it's 1040. It's more than 1,000, as the total earned value is more than 1,000, which means you should have invested more at a greater percent than the lesser percent, and hence this value would definitely be greater than 4%. Because as I have to earn more, I have to invest a larger value on the 6%, and that's why it would be then and only then it would be more than 1,000. Suppose if it was given the total interest at the end of the year was not 1040, but it was given as 940. Now, since the actual interest in, if it was given as 940, that means I have the total interest now on equal coming out to be 1,000, which is greater than 940. Now that is not allowed. So I should have more money invested at 4% than at 6%, so that the total return would become less than 1,000. Okay, now what are these values? I'm not interested, because we just needed to compare, right? So in such cases, whenever you have to do comparison between two quantities, the simplest thing would be, first of all, assume them to be equal. Agar equal hote to kya value hoti, and then simply cross check, and accordingly you can decide whether which of the two quantity should be greater or lesser, right? In fact, some of the approximations that you guys suggested are also very much correct. You could have used that logic also. Okay, the idea is just come up with some approximation, okay, where you can avoid the detailed calculation. Just think of a way which you can relate and approximate and work, which somehow helps you to cut down on your solving part. Okay, that's all what you need to work at. Okay, so A is the right answer. Okay, now let's look at this part. Okay. D20. Yeah. So it's the same thing that we were discussing, where you have the difference between the simple and the compound interest part. X invested some money, you know, 2 years at simple interest, whereas Y invested the same at the compounding, annual compounding at the end of 2 years. Apart from the amount of which X received 200 interest, Y received 220. What was the rate of interest percent per annum? So what you can see here, the difference between CI and SI is 200 and 220, which is 20. Okay, and we don't know the principal. Okay, and we don't know the rate of interest, although we know the difference. So how do we work it out? That is given as P R square over 100 square, right? So here we have actually two unknowns. We don't know P and we don't know R. That's fine. Any suggestions? If we use this formula, so PR square. So if you cross, give you 20 into 100 square is PR square. Find PR using simple interest formula. Okay. And that is substitute there. Okay. Because I know the simple interest is 200. So 200 equals to P into R into N, which is 2 over 100. So this cancels 100. And therefore, PR is actually 100 square. So this would become 20 into 100 square, which is PR into, right? So this PR is 100 square, right? And hence R is the 20 part. So you can say R equals to 20%. Right. Okay. So I use the simple interest formula from which we can calculate PR, and PR square actually can be split as PR into R. And you know exactly which part would be equal to the square part, and the other one would be the R%. Okay, so equating that, PR is the 100 square part, so R has to be 20. Okay, this is one method, right, where you use the idea for both of it and try to work out. Now let's also look at one alternate method here. Okay, now what you see that this difference CI minus SI, actually you can just take the formulae for SI CI, simplify and solve for 2 years, which will reduce to this one, PR square on 100 square. It's just two three more steps that you get to it. Now let's try to rephrase this thing and look at a lot easier way to work. So R by 100 into R on 100 into P. This is what I can split this out. And if you see this portion, R by 100 into P basically is nothing but the R% of P. You're finding R% of P. Now R% of P actually is the first year's interest. Whenever you're calculating the interest on the principal value, this is what you're calculating the first year interest, whether it's on the simple or on the compounding basis. The base value for both is principal, and hence they will always be the same. For the first year, simple and compound interests are equal. It's only from the second year it starts building up on the compounding part, because you're charging interest on the interest. And this can be simply written as R% of your first year's interest, right? So the difference between compounding and simple interest is just the R% of the first year interest that you have, right? So I'll use this logic because this is what we have done in the previous session. If you you see that X is paying interest of 200, for 2 years, since it is on a simple basis, X is using the simple interest, the interest paid would be equal, which will be 100 plus 100, whereas Y is paying on a compounding basis, which is 220. Okay, now this is just the split, you're doing it mentally. I'm just writing here for the sake of that. This 120, now first year's interest for both of them would be the same because it is calculated on the principal value. It is 120 in the second year. Okay, so first year's interest is equal. That's equal for both of it. Is there where you get the difference of 20. Should earn 20 more. Now we know that this difference, is actually R% of the first year's interest. And how much is the first year's interest that Y is getting? 100, which is same. So all I need is R% of the first year's interest, which is 100, is 20. So what percent of 100 would be 20? It has to be 20%. And hence R is simply 20% of that. Okay. So I don't have to again get into this PR square upon 100 square the thing, or go back and find interest, say the PR part. You can simply see it as one single value, which is nothing but R% of the first year's interest. As you get to know the total interest, okay, you can split that up. Simple interest पे equal होगा 100, compounding पे 220 है, which is 100 plus 120. So difference 20 है, first year का interest 100 है, and the difference actually is equal to R% of the first year's interest. So R% of 100 should be 20, which means R has to be 20%. Okay, this is just a direct way of looking at the same thing. Okay, where you don't need to get into too much of calculation. In fact, either the difference दिया है. If suppose you are asked to find the difference, let's say, okay, two friends X and Y, took a loan of 15,000, or let's say, in fact, make it 20,000. Okay, 20,000. Okay, at the rate of 15% annually. Okay, X does on a compound simple interest, whereas Y on a compound interest. So X took interest on the simple, whereas Y took it on the compounding. How much more interest did Y ended up paying as compared to X? Okay, so one thing is, of course, this will always be for 2 years. This is true only for 2 years period, and they'll ask you only for the 2 years period. Okay, that's most of the questions are directed for 2 years interval. Now, there's no need to calculate the simple and the compound interest and then take the difference, right? You can just see, we are interested in finding out the difference. What would be the interest for the first year? In either of the cases, it's going to be the same, which is 15% of 20K. Okay, 10% of 20,000 would be 2,000. 5% would be half of 2,000, which is 1,000. So 15% is 3,000. So we know that first year interest is 3,000. The difference, CI minus SI, is just simply R% of the first year's interest, which is going to be again 15% of this 3,000, right? 10% of 3,000 is 300. 5% is half, which is 150. So therefore 50% is 450. So hence the difference between CI and SI for both of them would be $450. So Y ended up paying 450 more as an interest as compared to simple, as compared to S. It's just the calculation that you need to do for 2 years period. Okay, you can calculate the interest individually and then subtract and check. This will give you the same value. So this saves on a lot of time. Okay, using out this one. This is the same thing you can also use for your compound interest wala formula, one on a yearly basis, the second on a half yearly basis, because again there are two cycles for compounding semi-annually and one cycle for a yearly thing. But there, if you when you use this, you have to take half of the R value. Remember that, because semi-annually mein, it's not R%, it's R by 2, the whole percent. So if it is 10%, then you have to use 5% for your calculation. So 5% of the first interval's interest, which should be the difference between half yearly and yearly thing. Because that is one of the questions that is asked again commonly. that what would be the equivalent, part in there. So the equivalent, I'll just take that extra question on the interest part, and that will, then finish us with the overall percentage part of it. All the questions of percentage and the application of percent. So if it is given, a person, okay, is charged some interest at 6% half yearly. Okay, so he is charged at a rate of 6%, okay, half yearly or semi-annually. Now, if he has to interest and the same interest, then what percent should he charge on a yearly basis? Okay, so the compound interest earned at 6% half yearly basis is equal to what percent on the yearly basis? Is the question clear? So on the same principal value, if you charge at 6% half yearly, you earn certain interest at the end of it. If you need to earn the same interest at the yearly basis, what should be the rate of interest? Okay, which is like finding out the equivalent of a R% half yearly. Okay, to earn the same interest. In this case, if it is 6% yearly and 6% half yearly, 6% half yearly will earn you more interest compared to 6% yearly. Okay, so 6% half yearly will earn you what interest at a yearly basis, and you have to find out that equivalent value. All right, try this out. Twelve point 36, right? That is going to be way too much. 12.36, you guys would be ripping him off. That's nearly more than the double. 12.36 yearly is way too high. Just, no, not this much, of course. It's way too high. Very, very much way. 6.09, yes, correct. That's the right one. 6.09 is correct. So my question was, 6% half yearly. See, again, 6% is not the half yearly value. What I said, the R% is always given as a PCPA, and then you need to take the half of it, or a 1/4, depending on whether it's on a half yearly or a quarterly basis. So take a compounded annually 6% at a half yearly thing. Okay, what would be? Correct. Possibly you would have taken 6 as R by 2. So that way, yeah, that possibly you would have missed out. The rate, the interest part is always a yearly basis. You have to take the half of that part. Correct. So for this one, okay, let's say the interest part was, the interest part that we have here is R by 2, which is 3%. Okay, So 3% would give me a total compound interest. Let's say it was 100, 103 the whole square on 100 square minus 100, okay, which is what I'll earn at a half yearly basis for 2 cycles, first 6 and then another 6. So that is 100 cancelled over the square. This is 106.09. 103 square is 3 square 09, and 103 plus 3, which is 106, divided by 100, 106.09 minus 100. So the interest part is 6.09. Okay, so on 100 at the rate of 6% half yearly, you're going to earn an interest of 6.09. Okay, if this is the same interest you have to earn on a yearly basis, then on 100 I would be charging an interest of 6.09, right? Again, it's not 6.9 starts, you have to add a 0 also, right? So 6.09. 6.9 will be as good as 7, which will be high, right? So you can now devise a formula for it. So what happened? That was this R. First thing is I'll split as R by 2. No? This was 6 and this came out to be 3. Agar suppose 100 tha principal, ye first 6 months and the second 6 months, right? Wo split it tha. So either tha 3% of 100, which is 3. ये 3% इधर भी calculate किया, but इधर extra क्या आया? 3% of the first value, which is 3, which was 0.09, and hence in दोनों का addition 3 plus 3 6 plus 0.09 6.09. So here you can say this was R percent. Okay, तो extra कितना है? ये जो half होता है, this is the extra part. 3 plus 3 is actually equal to 6, जो 6% year में आएगा. So effective rate of interest will become R plus, this is R by 2% of R. So R by 2% of R, which is R by 2 the whole square upon 100. If you look at the formula correctly and the percent of that. So this is the effective yearly interest that you should charge for R% half year, which will fetch you the same interest at the end of the year. Okay, so whatever be the R value, this is what you'll see. So in this case R is 6, correct? R% जो है वो 6 है ना, तो कितना हो जाएगा? 6 plus 6 by 2 3 square 9 upon 100, right, which is 6.09%. Okay, similarly agar this was given at, if this was given as 10% half yearly, right, then what is the equivalent rate? Well, I'll simply say this is going to be 10 plus half of 10 is 5, 5 square 25, 25 on 100 is 0.25, and hence the effective yearly interest would be 10.25%. Okay, this gives it to you in a couple of seconds. So you can use this result directly. Okay, so this is one of the types that you can use for that. All right. So here in today's class, we ended up covering all these types of questions, challenge a little, basics and the medium ones on the percentages, and then also the application to the simple and compound ratios. Yeah, okay, I'll send you that. Yeah, I'll just type in here. I'm just writing it here. Can you just make a note of that? I'll just write down here. That's, you can mail me at iitb.in@gmail.com. Okay, that's iitbombay.india, the short for that one. Okay, iitb.in@gmail.com. Book Akshat, I'll just try to check because I don't know, what is the program details of the program, I'll have to check it with my colleague, as in what are the material that you would be receiving. Okay, because he's the one who's coordinating with your college, right? So I'll see what is it that is worked out, and accordingly then I'll let you know what are the things that you can practice on. Okay, so by the next session, by next Monday, I'll let you know, and if there is something that I have to share, I'll also share it out here. Okay, so in the next class we will go through the questions on ratios, the theory and the problems on ratios, and then we'll also do a little bit of advanced problem solving on percentages and ratios combined. So looking at certain challenging and tough questions by the end of it. So we cover the ratio theory, problems, and a quick revision of tough questions on the percentages and ratios. Okay, that is what we're going to do on next Monday. All right. Okay, guys. I'll be signing off for now. I have another session later. Okay, take care. Study well. Stay safe. Any idea if the colleges are opening up? Any circular that you got? I think because slowly and slowly things are just working out. Nothing yet, right? Okay, take care. Not a problem. Okay, so I'll see you then again next Monday, where we'll cover up with this part. Okay, you can just send me on my email ID for the record. Okay, guys, thank you so much. I'll see you then next Monday. Okay, take care. Good night.